Right, in lesson 6 we'll be simplifying exponential equations where the unknowns are exponents. So you can see them unknown. The power x is the exponent, and we'll be solving problems in that order. I'm proud of you, the fact that you're still here. I hope you understand and you're following me. As I said, it's just patterns that you have to learn. The more you practice the patterns, the more they stay in your head. So first, to solve where the exponent is an unknown, we have to ensure that the bases are the same, right? So 8 can be expressed with base 2. So as a prime factor, that would be 2 to the power 3. Right? If it's positive at the bottom and I take it to the top, it becomes negative 3. So now you can see my bases, base 2 are the same. So I drop the bases and I'm left with x equal negative 3. So if my exponent is unknown, I have to ensure that my bases are the same. Right? Problem number 2. Right, so yeah, we're giving you exponential equation, but they're separated by a minus sign. Right, so again, with minus or plus sign, we have to take out the common factor. But to make sure you don't make an error, we're gonna first split and then factorize. So there, if I split that, that's 3 to the power x times 3 to the negative 2 equal 24. Take note, in reality, the dot must be there in the middle to show multiplication, but most the time nowadays they just type it at the bottom. So there, 3 to the power x, 3 to the power x. If I take it out as a common factor, anything divided by itself, 3 to the power x divided by 3 to the power x gives me 1. There, if I divide 1 times anything stays the same, so I'm left with 3 negative 2 equal 24. So in the bracket, this becomes 1 minus 1 over 9. 1, 3 negative 2 go to the bottom, 3 squared is 9. So 1 minus 1 over 9 gives me 8 over 9. To get rid of this, remember I want to solve for x, so I want that on its own. That would become 24 times the reciprocal of that, 9 over 8. So I simply flipped 9 went to the top, 8 to the bottom. So 8 goes in 24, 3 times 9 gives me 27. Right? So from there, make the bases the same. So 27 can be expressed as 3 to the power 3. Now because the bases are the same, I can drop them. And I'm left with x equal to 3. So you're following the procedure? Hope you understand. I hope the color coordination makes it easy for you. Pause, look at the problem, rewrite it, redo it. Practice makes perfect. Right, and then last problem, number 3. Still exponential equations. You're given 3 times 9x minus 1, 27 to negative 3. Again, whatever is not a prime number must be expressed as a prime base. So 9 becomes 3 squared. 27 becomes 3 cubed. Very careful when you multiply, everything inside must be multiplied with everything outside. So 2 to the power x, 2 times x gives me 2x. 2 times negative 1 would give me negative 2. 3 times negative x would give me negative 3x. First law of exponents, if the bases are the same, we add the exponents, so that becomes 2x minus 2 plus 1, and there simply stays negative 3x. Right, minus 2 plus 1 would give me minus 1, so I have 2x minus 1 minus 3x. Bases are the same, so we can drop them, so I'm left with 2x minus 1 equal minus 3x. If I take 3x or transpose it across the equal sign, negative becomes positive 3x and minus 1 becomes plus 1. 2x plus 3x equal 5. 5x equal 1, and remember objective is to solve for x, so we have to divide by the coefficient there, so that simply becomes 1 over 5. Hope you enjoyed the lesson. I hope you followed. I hope you can see it's just procedures. Say pause, rewrite the problem, read to it, practice it over and over till you get used to procedure. With enough practice, you will succeed in maths. Guaranteed. Right? I wish you nothing but the best.